Hello everybody, this is Ziyang Tang from stat512 and here is my presentation on Project 10. The project aims at the CDI datasets, and the goal is to find the relationship between the response variable of the rate of the serious crimes between other features from the dataset. The sample size is 300, and my hypothesis is the standard multilinear regression model to determine whether at least one of the betas is not zero. Okay, now let's have a look at the dataset. It contains 17 variables, but in this study, we're only focusing on the continuous variables. Therefore, I removed the column of ID, the name of the county, the name of the state, and the region. Note that the personal income is the result of multiplication of the population and the capital income. So in this case, I also removed the column of the personal income to avoid the interaction of the variables. Okay, and here is the subset I used to build the linear model. The response variable y is the result of the deviation of the total crimes and the total population. Then follows the 11 explanatory variables, and all the data were rescaled to the range of 0 to 1. Then I built up the linear model and check the assumptions of the variables. Here is the visualization plots from the output of R. From the residual plot, it seems that the model might be quadratic, but it's not very obvious, and there exist several outliers. For example, the 0.3, 0.9, and 0.277 that might affect the relationship of the dataset. So in this case, it could be linear but with outliers. And from the QQ plot, we can see that most of the points follow a straight line, but there's two obvious outliers, 0.1 and 0.3, that might make the whole dataset violate the normal distribution. From the third plot, we can see that the variance is actually going up. So in this case, the dataset might have a problem of the violation of the constant variance. And from the fourth plot, we can see two obvious outliers, 0.1 and 0.3. So since the outliers might have very serious issues on this dataset, so I decide to remove 0.1 and 0.3 and redraw the whole plots. So after remove the inference points, we can see that the residual plot looks much better, but it could be a linear relationship because although the line is not that straight, the difference is only like 0.1. So from my opinion, I think it should follow the linear relationship. And from the QQ plot, we can see that the lines are actually follows the straight line, but it could violate the normal distribution because there still exists some points like 0.9, 0.277, and 144. So further tests should be applied to confirm this. And from the third plot, we can see the variance is actually going up. So it might have an issue that this dataset will violate the constant variance assumptions. And from the fourth plot, we can see that the major influence point has been removed. So to confirm that whether this dataset is violates the constant variance and the normality, I run the BF test and the Champerot test. So for the BF test, I cut the dataset into 5 groups, and surprisingly, the result shows that the dataset has no evidence to violate the constant variance assumption at the level of 0.05. And the Shenpro test also shows that there's no evidence that the dataset violates the normal distribution. So in this case, since the BF test and the Shenpro test also shows that the dataset follows the constant variance assumption and the normal distribution assumption, there's no need to apply the data transform methods in this dataset. Therefore, I run the model with after removing the inference points, and this is the ANOVA table using the time to error to show that whether all the variables are needed in the dataset. So when I run the ANOVA test, you can see that if other variables are given, x1 can actually be dropped from this dataset. And so therefore, I want to determine whether which variables are actually needed for the dataset. So I use the automatic model selection method in R to find the best model for me. And here is the result from R from the model selection algorithm. And I summarized the best parameters from each criterion. As you can see, the CP, AIC, and the PRESS also show that when P equals to 5, the model is the best from the subset. And so therefore, I use the majority votes here, and I select P equals to 5 as the best model. Then I build up the best model from the model selection results using X3, X6, X9, X10, and X11. And the ANOVA table shows that even given other variables, for example, given X6, X9, X10, and X11, S3 is still significant, has the significance impact on the Y. So in this case, it should show that each variable is very important, and there should have no collinearity from the model. But to make sure, I also draw the correlation plots and run the test of VIF. So from the correlation plots, we can see that there's no evidence showing that two of the variables are highly correlated with each other. And the VIF also shows that the variables has no evidence of highly correlation effects, because the most for the all VIF results, the result is really close to 1. Finally, I use this best model as my final model, and I summarize the estimates of the beta and the standardized errors of this model. So in conclusion, at least one of the variables from the young population aged from 18 to 36, or the number of the active physicians, the percentage of the 25 or older adults with a bachelor's degree, and the percentage below the poverty level, and the percentage of the unemployment could have the significant effect on the rate of the crime in this county. So that's all for my presentation. Thank you.